To draw the last graph, or the last several graphs, I had to use a set of axes, one for each variable that we have in our equation. The standard way to set this up is to label the horizontal axis the x-axis. So this demarcates how our x values change, and the vertical axis the y-axis, showing how y values change. Now every point on this plane is associated with both a value in the horizontal direction, an x value, and a value in the vertical direction, a y value. I also mentioned earlier that we identify points on our coordinate plane with a special notation. The first number listed is our x-coordinate, or our horizontal position, and the second number in the ordered pair is the y-coordinate, or the vertical position of the point. The arrows that you see on the ends of each axis represent continuation. So the x-axis continues all the way out to infinity, and also in the other direction, all the way out to negative infinity. And the same is true of the y-axis. So with this coordinate plane, we're really able to represent, if we want to take as much time and paper as possible, any combination of two real numbers. And then, of course, we can depict it graphically. There's one single point on this graph, however, one point out of that infinite number of points that's really special, and we call it the origin. Which point of all of these ones highlighted in teal do you think is special enough to have such an illustrious title as the origin? Click where you think it is.